So, today we're focusing on regular polygons. Now, we've mentioned the term regular polygon before, but it's been a minute. A regular polygon is a polygon that is both equilateral and equal angular. What does it mean for it to be equilateral? All sides are congruent. What does it mean to be equiangular? All angles are congruent. These are the larger polygons that you generally think about, that you picture most of the time. Because when you went through elementary school and were introduced to shapes, these are the ones they showed you. They showed you an equilateral triangle. They showed you a square. They showed you an equilateral pentagon, an equilateral hexagon, heptagon, octagon, nonagon, decagon, hendecagon, and dodecagon. We named them a while ago. I don't expect you to remember the names of all of them. Some of them you should know.
I know a sphere.
Not a polygon.
Oh,
Not two-dimensional.
close enough.
No. Okay, now, when it comes to working with our regular polygons, there are some specific points and some specific features of them that we have to know. First off, the point that is equidistant, in other words, the same distance from each vertex, which is the corners of the shape, is known as the center of the polygon. Now I've got a regular polygon here inside of a circle. What is the center of this hexagon right here? Well, yeah. So like point P in that picture is the center. Now the reason that this hexagon is hanging out inside of a circle is because of the next term. When it comes to these polygons, the distance from the center to the corner, to the vertex of the polygon, would be the exact same as the distance from the center of the circle to the edge of the circle if it was stuck inside of a circle. What do we call the distance from the center to the edge of a circle? Radius. It is also known as the radius of a polygon. So segment PM or segment PN in that shape would be referenced as a radius. Now, to be honest with you, in the ones that we're going to look at, we're not going to need the radius so much, but it's just an important feature to know. They also have distance from the center to the side of the polygon, specifically the center of each side of the polygon. This would be like the segment PQ. And it is known as the apothem. The apothem is a very important feature of these polygons. It's going to be one of the ones that we focus in on that we're actually going to need to know a little bit more. Last thing that we're talking about is the angle formed by two radii, oh my goodness, drawn to consecutive vertices of the polygon. So like the angle MPN. That angle there. It's It's known as a central angle of a polygon. Now, the reason that we focus in on all of these various things with these regular polygons is the fact that focusing in on a lot of these things is actually how the formula for the area of a regular polygon is discovered. Because when it comes to working with these regular polygons, by drawing in all of the central angles, you end up making a bunch of equilateral triangles. And so finding the area of this regular polygon is using all of these triangles put together. Now, when it comes to these shapes, the key thing that I want you to focus in on is not the center point, is not the radius, and is not the measure of the central angle. It is the apothem. So we're not going to identify all those things here. We're just going to identify an apothem. Apothem goes from center to edge of shape. Not to the corner of the shape, to the edge of the shape. Which segment on this shape goes from center to edge? G is a singular point. FG. And if it's a segment, it's got the bar above it. What about on this one? GH. Could I have named them in the opposite order? Yeah. Doesn't make a difference with a segment as long as the 2 points are the endpoints. So this leads us to being able to find the area, which is what we're talking about on the next page. And, for that matter, the perimeter. Because regular polygons are one of the few shapes that actually have a perimeter formula. Area of a regular polygon, there are 2 formulas actually for it. And we're going to talk about perimeter formula here as well. One formula is 1/2 ASN. The other formula for this we're going to talk about here in a minute. But first, we got to talk about what A, what S, and what N are. A stands for the apothem. S stands for side length. And N stands for the number of sides. This formula comes out of the fact that if I take a regular polygon, such as this one, which has 6 sides, again, I can break it into all those triangles, which this one's done for us. How do you find the area of a triangle? 1/2, what's the formula? Base times height. If you look at this triangle that's drawn in right here, what would be the base of that triangle? S. What would be the height of that triangle? A. And how many triangles are there? Don't count this as 2 triangles. This is just 1 triangle. 6. There are 6 triangles because how many sides are on the shape? 6. Hence, you multiplied the individual triangle area by how many triangles there are, because all of these triangles should be congruent, because by definition it's a regular polygon. This formula only works if it is a regular polygon. If I gave you a pentagon that looked like that, the formula would not work because not all of the side lengths are the same. So 1/2 ASM. Why did they put it in that order? I have no earthly idea. That's just the order that we typically put it in. Put the laptop away, please. Thank you. Okay. Now, I'm going to go to the perimeter formula before the second area formula. How do you typically find the perimeter of shape? Add up all the sides. But if all of these sides are the same, and I call them S, that means this is S, and this is S, and this is S, and this is S, and this is S. And so I would do S plus S plus S plus S plus S plus S. What is S plus S plus S plus S plus S plus S?
6S.
6S. But remember, the 6 corresponds with what about this shape? Why are there 6 S's? Because there's 6 sides. Which means you can do S times N to get the perimeter. So the other formula for area is 1/2 times the apothem times the perimeter, if that's what you're given. We're generally not going to use that formula. I'm going to tell you that straight up. We will probably not use this one. And if it's going to confuse you and you want to just be like, I don't really want that one, that's fine. But I like to at least show it to you because it's a useful thing to know if they give you weird information. I'm not trying to give you weird information. Okay. We want to find the area of the following. Note, I did not ask you to find the perimeter, not because it's not an important thing to know, but because I have a feeling you can multiply 2 numbers just fine. And so for the sake of time, we're going to not find the perimeter on them. Okay, so I got this shape here. What shape is it?
Polygon.
Polygon. Be more specific.
6-sided shape.
What is a 6-sided polygon called? Hexagon. Technically, you could call it a 6gon. You're not wrong. Regular hexagon. Area equals 1/2 ASN. Do we know what A is? A is the apothem. What length is the apothem on this shape? 1.5, center to edge. That's apothem. Do we know S? Two. Do we know N? 6, because the number of sides were 1, 2, 3, 4, 5, 6. N equals 6. So area equals 1/2 times 1.5 times 2 times 6. Now what? You put it into your calculator. Nine. 9 what's? Feet squared. It's an area. If I had asked you to find the perimeter, what would you do? SN, so I heard someone say it, 2 times 6. And you would have gotten 12. Now, just for the sake, I'm just writing this once. I'm not going to go through the perimeter every time because I don't ask for that. But I just want to double check something. Yes, you do 2 times 6 and you get 12 what's? Feet. Not feet squared. The only thing that has squared units in this chapter is area. Okay. Problem B. Also a regular polygon. What kind of polygon? Pentagon. Now, I am not testing your knowledge on the name of these shapes in this chapter, but it is going to come up next chapter. Hence, we're getting a little bit of practice, getting the rust off a little bit. Okay, regular pentagon this time. So 1/2 ASN. Do we know A?
14.
Do we know S?
20.3.
Do we know N?
5.
Where's the 5 coming from?
All 5.
1, 2, 3, 4, 5. It's because of the number of sides. Do you have to write that out every single time? No, absolutely not. You just need to know what it is. So 1/2 times A times S times N. And you type it into a calculator. Now I put 0.5 into my calculator for the 1/2 before. What's another way I could put 1/2 into a calculator? 1 divided by 2. $710.5. We don't know the units, we just put units squared or U squared. What do you notice about question C?
Triangle.
It's a triangle.
Do we like triangles in this chapter?
You tell me. When it comes to triangles, we have a formula specifically for triangles. 1/2 base times height. Do you know a base of that triangle?
No. Yes.
You do.
3.5.
Not 3.5. 3.5 is not a base. 12 would be a base because a base is a side length. The height has to be perpendicular to it. I see a right angle right here, but is this a height?
I thought the base came from the right angle.
It does. Right angle right here. Technically this should be the base. But since it's a regular polygon, according to the instructions, this would be 12. The 3.5 is not a base. Or, sorry, is not a height is what I meant to say. Because height is perpendicular to the base and needs to go all the way across the shape to the opposite vertex. You cannot, because there's nothing that says this length and this length are the same. Actually, the relationship is 1/3 to 2/3. But you don't need to know that. A triangle, if it is an equilateral triangle, and I know this is an equilateral triangle for one reason and one reason only. The instructions told me it's a regular polygon. Being a triangle does not change the fact that it's a polygon. I'm still going to use this formula because it's still a regular polygon. Even if it's a triangle, it is a regular polygon. Do we know the apothem?
Is that 3.5?
That's what the 3.5 is. Do we know the side length? That's what 12 is. What's n? 3 is a triangle. 63? Assuming I did my math right. The point of this problem is to point out the fact that when it comes to our shapes, you actually can find the area of them multiple different ways, depending upon what information you know about it. If it tells you it is a regular polygon, I promise you we're going to use the regular polygon formula. I believe the next page is composite shapes. Yep, that's right. We're going to be done right there. This one's doing the exact same thing. The only thing different from shape to shape is you have to count the number of sides, and the number of sides changed.
So we're done with notes?
Yes.
Yay.
We are done with notes. Yes. Unless you want more. Do you want more? I could do more.
No, I'm ready.
Okay. So today is 22nd. Homework's due on Thursday, 24th. 11.3 worksheet 3. Ooh, my pen is dying. Okay, 11.3 worksheet 1. That's the kite and rhombi worksheet. Is due today. You have a large chunk of work time to be getting stuff done today.